Okay, so here we are asked to explain the paths of the two light rays shown in the diagram after they strike the boundary between air and water. This does ask you to include calculations and to draw on the diagram to support your answer. So potentially quite a tricky one to know what to do here. Explain the paths. Well, if you look at the diagram, we haven't got the paths. So the first thing you have to do is actually identify what are the paths going to look like. Now, we know that they are striking a boundary, and we know that two things can happen when you strike a boundary. You will either get refraction or you will get total internal reflection. Now, the thing to bear in mind here is that we are going from the air into the water. And actually, we don't get total internal reflection happening when we have a less dense material to a more dense material. So the first thing to identify here is that actually we are not going to get total internal reflection. So if total internal reflection isn't taking place, it means that actually we are going to get refraction happening. And the reason that refraction is happening is because that we have a different density of material. So the water and air have different densities. And the fact that the water is more dense than the air means that actually the light is going to travel slower in the water than it will in the air. Now we know that if the light is slowing down, then that should mean that it would bend towards the normal. So we've got the explanation of what's actually going to happen. We're going to get refraction happening, and that means that the light is going to slow down and bend towards the normal. But as you can see in the question, we are asked to include calculations and draw to support your answer. So what we now have to do is show exactly what that ray is going to do. Now, in order to figure out what the value for the angle of refraction is going to be, we need to go to our formula sheet and we need to use this formula here. Because if we look in the question, we are given n, this is our 1.33, and we are going to be trying to find this value for r so that we can draw it onto our diagram. So what we now have to do is take a value from the diagram for either A or B for that angle of incidence. So if you do that, you will get an answer of anything between 34 and 38 degrees for A, and you will get an answer of 58 to 62 degrees for B. So clearly draw on your diagram, add the normal, and show where you've calculated or measured that angle from. Having done that, we can then plug that into our equation. So we know that 1.33 is equal to sine of 38 divided by the sine of the angle of refraction. If we rearrange that, we have the sine of the angle of refraction is equal to sine 38 divided by 1.33. Now that gives us a value of 0.4629. So we now want to find r. So to find r is the inverse sine of that 0.4629. And when we do that, we find that r has a value of 27.57, which is approximately 28 degrees. So we've now done the calculation. The last thing we need to do is to draw on the diagram to support our answer. So this is for ray A that I have done. If you do ray B, you will end up with an angle of refraction of anything between 39 to 42 degrees. And A acceptable values are 24 up to 28 degrees. So having done your calculation, you then go back to your diagram and you draw on accurately using a protractor either one of these rays.